Hello, everybody. Welcome to Timescale Office Hour, Wednesday, October the 19th, 2022, midday Eastern Time, and 3 a.m. in Australia, it would seem. So let's just move on from that. But he's back in control. This session is recorded. Mic and camera off is absolutely fine. If you would like to make comments or ask questions, but you want to be mic and camera off, drop them into chat and I'll represent them to James and the rest of the people who will be here. I think David was heading in. We should have a few more. So welcome Brandon, Frank, David when he gets here, and I think we'll have a few more very, very soon. Okay, so I'm Lorraine Pocklington. For those that you haven't met, Lorraine P on Slack. I'm community manager here at Timescales. I'm up in West Wales, UK, and you can find me on Twitter at @𝗥𝗲𝗹𝗲𝘃. Pleased today to really introduce 𝗥𝗲𝗃. 𝗥𝗲𝗃's a little bit like our new Jill to some extent in the context of these office hours. She's a marketing coordinator. Correct me if I got any of this wrong, by the way, 𝗥𝗲𝗃 from Detroit in the USA. So if any of you head into KubeCon, you might be able to say hello to 𝗥𝗲𝗃 there next week. And you can find her on Twitter too. So step in if you'd like to say anything about yourself, 𝗥𝗲𝗃, or we could just move on to James.
No, you had everything correct, and I will be at KubeCon, so please say hello.
Excellent. And last but not least, by any means, we have James 𝗥𝗲𝗃𝗀𝗃, who's the Senior Director of Developer Advocacy here at Timescale. He's in Sydney, Australia, so he's honouring us here at 3 o'clock in the morning due to other members of the team being all over the shop and travelling right now. And you'll find James and James Sewell. You'll also have come across James quite a lot if you've been in Slack a long time, I think, because that's where we found him. Okay. So at this point then I'll move on to the next slide. We have a conversational question which we, the people here are great for this, especially David should show up, others will show up, and we'd love to have some thoughts on this for a community member who can't actually appear today. So okay, James, are you happy to go through this lot, or?
I am. So
fabulous.
Actually, maybe go back a slide for a second. Maybe how many people? So I'll just say a bit about my background, maybe, because it's maybe slightly different to other people's background. So yeah, I'm the Director of Developer Advocacy, or actually, as I saw some slides the other day, the Directory of Developer Advocacy snuck in somehow. Not really sure how that works. I'm in Sydney, but feel free to ping me on Slack whenever you need to. I'm in the community Slack. My background, which is probably a bit atypical for a developer advocate, although kind of similar to Ryan, is I, for many, many years, was architect. So I was the chief architect of like a medium-sized consulting firm. So I'm very used to talking to people about their problems and then trying to work out how they can solve them. So I'm from I suppose the architecture side of the fence rather than the developer side of the fence, although I've done a bit of development in the past as well. That'll do. You want to go to the next one? Yeah, cool. So Timescale community requests at the moment. So the top upvoted requests, I think the same as like, well, actually we pushed a few of these off with 2.8. So I think if we looked at this last time, we would have seen there was one for doing update on insert with an index, which 𝗥𝗲𝗃𝗀𝗃 was really into. That was closed off between now and the last session. And there was also another one that's, I'm not thinking of it at the moment. I'll come back when I remember. But at the moment, the top upvoted requests are allow inserts, updates, deletes to compressed chunks, which obviously is always super topical, also is quite hard. So we're continuing to hopefully make progress on that. 𝗥𝗃s on 𝗥𝗃s, which is happening hopefully quite soon. I see people talking about that quite often in our internal Slack. So that is when you want to have a continuous aggregate for, say, weekly roll-up, and sorry, other way around. You want to have one for monthly, and then you want to put one for weekly on top of that. No, other way around. That's going to be a super great feature. Personally, I'm waiting for that before I can do a bunch of demos that I want to do and the team wants to do. So as soon as that happens, we're going to be talking about it a lot, and there'll be articles. And you don't need to worry about missing it because you will know there'll be content out there for it. Support for joining time series via as of time. So that's to do with time zones. Hopefully that's happening soon as well. And then I suppose a couple of these talked about ones. So adding an offset option to time bucket gap fill in the same way that time bucket has it, which will be happening, and insert into a compressed chunk with primary key fails. That's worded strangely. I guess that's an upsert into a compressed chunk. And some new requests. Does this mean that they're new requests since last time, Lorraine, or are they just the newest ones in there?
Unmute. So the newest requests are the ones that are listed as newest on our Monday morning report that gets auto-posted to Slack.
Yeah,
cool. So they're the latest of requests that we have.
Cool. So this first one is actually super interesting because I saw this on here and thought, wow, that's actually something I personally ran up against last week. So I was trying to do some testing with some triggers and found that you can't actually disable a trigger on a timescale table. And the reason for that is almost certainly that we didn't want people to disable our trigger, but I mean, it's been extended to all triggers, which is a bit disappointing because there's no reason for it to do that. So that's been listed as a bug, which is great because it could have gone either way. So we'll be getting that fixed. Forcefully remove data nodes. That's a feature request that's just about ripping data nodes out of multi-master forcefully, so not waiting for them to gracefully exit, which is always a good thing to have. Time shifting is an interesting one, so that's shifting a series back and forward in time. Actually, again, something in the last week that I've been thinking about because I've been doing a lot of stuff with benchmarking, and we've been recording our internal benchmarking data into Timescale, and I want to display one benchmark run over the top of another. So I've been kind of doing that manually. It'd be great if we had a function to do it. Time weight standard deviation, that's just another hyperfunction that hopefully will get done.
James, going back to the previous one,
yes.
Are you actually talking about modifying the data in the database to shift a series, or just having a time shift filter applied?
So it could be either. Obviously, it will just be a function. You give it a time series, it will time shift that. Whether or not you write that back to the database, whether that's an update statement, whether it's a select statement, is up to you. In my case, all I want is a Grafana graph that shows a benchmark run that I've just done over the top of what I did last week, so I can visualize what the difference is without having to put the graphs next to each other, because human eyes aren't very good at that, right? But yeah, it would be for either. If you wanted to then write that back to the database, that would work as well.
Thanks.
And it's obviously not, like, you can do it in SQL, but that's kind of our mantra, right? Like, why should you need to work out how to do that yourself when it's a common thing, or just make a hyperfunction?
We can also do it in the Grafana client, but
you can do it in the Grafana client, but it's just not as convenient.
Agreed.
And also, I think sometimes putting that stuff in the Grafana client, I think as Grafana gets more complex, has another problem, which it's harder to discover some of that stuff.
Yeah, we don't like to distribute our apps so that one piece of code is inside the database, one piece of the code is in the client, and one piece of the code is in an SQL statement. That's hard to support.
Yeah. Cool. And then right at the end there, we've got enabling the origin parameter for time bucket for integer-based time columns. So we've got that for time series-based time columns, but for whatever reason, it didn't make it for integer-based time columns. So we're getting that enabled. So that's about when you want to have an origin of your time bucket, which is different, which is not based on the current time zone, which is kind of like quite niche, but there's people out there that are looking for it, obviously, because it's a request. Cool. Any questions there before we move on? Nope. Next slide.
So with this one, James, just so that you know, most of them we went through last month. If you, cool. You can skip on through a little bit. That's fine.
Yeah, cool. So I suppose the thing to note is that there's already been a patch release for 2.8. an upgrade's recommended. It's not critical that you upgrade, but some of them do affect the output of queries. So I would recommend everyone to upgrade if they can, as soon as they can. I'm not going to go through the updates that we had in that patch. I suppose the one that I looked through that stood out the most was you can get some incorrect results with joining on CAGs in a very specific circumstance. But for the most part, it's a fairly standard kind of small kind of thing patch list. You should upgrade as soon as you can, but there's nothing in there that's going to crash your database or anything like that. Cool. Yeah, should we go to that? Should we? I think that's fine. Like the priorities, and they're the same as last time. They're not the same as last time, actually. Continuous aggregates migration has actually been done now. Query performances in particular in multi-node. So that's always a major topic at Timescale. There's a multi-node team. They're working on multi-node continuously around the clock, trying to make that better. And in Timescale Cloud, major Postgres version updates. So supporting Postgres 15 is very topical at the moment. There's a very large Slack channel that's talking about that. Multi-factor authentication is coming, I think, the end of the year in cloud. That's actually my favorite topic to go and look at because it'll enable us to have a decent API for Timescale Cloud, which is down there as programmatic APIs. Cloud service observability, metric export to Datadog and CloudWatch, that's actually happened. So we have that today, that's launched. The status page has launched. Correct me if I'm wrong, Lorraine, but I think GDPR has actually happened as well, and SOC 2 has almost happened. I think GDPR is through, SOC 2 not quite, but very much on the way. Yeah. Cool. Okay, good. So next, oops, I'm out of control. I'm so sorry. Now I've gone upwards instead of downwards. Right, here we are. Okay, and I just want to say that Charlie has joined us, who is not the person that asked this in the forum, but is from the same team. And so we haven't got as many of our regular team here, but even so, I think that David, Frank, and I think probably Brandon, if you want to type in any of your own thoughts into this, Brandon, please feel free. We can read those out. And James, of course, you'll be able to help. But here's our community question for this week. New to Timescale, currently planning table schemas. Lots of multiple types of devices and data sources that have overlapping fields and a bunch of non-overlapping fields. Often need to query and visualize data from different devices together. I'm reading this out, you can all read, I know. Is it best practice though? And this is to our community members too, as well as James, who used to be a community member. As I say, we kind of took him out of Slack and made him the Senior Director of Developer Advocacy here. But is it best practice to store them in separate hypertables and do joins using time buckets? Or would you recommend to use one big hypertable and let compression squash all of the unused columns when segmented by device? For reference, it's an influx background, so the context and knowledge and everything will be coming from that direction. Is that fair, Charlie? Thumbs up if you don't want to speak, but
that's great. No, thank you, and I really appreciate having this opportunity, and I'm glad you've picked it up as a community question. That's really helpful. I promised B that I would ask it, but then just to give some context there, we are the application here is flood sensors. We have a bunch of flood sensors going out around New York, and we also scrape in a bunch of data from random APIs like weather data, precipitation, that kind of thing. And yeah, we would like, should we have a hypertable for weather data? Should we have a hypertable for flood sensors? Or should we have a mega hypertable with just everything, with potentially a lot of empty rows, purely because the cadence and duty cycle of each of these sensors types is very different. The weather data could come in at every hour from particular stations versus every minute from our sensors. So variation in cadence is a thing.
So the database designer and computer scientist in me has a visceral reaction to sparse arrays in a single hypertable, right? Irrespective of how well that data is going to be compressed away, that just seems like bad design to me. You would deviate from that design if there was a really compelling reason to do so. So I've worked with databases in the past where the performance was so dramatic by just, forcing data in there with a value every 5 minutes, for example, for every single one, even if it was a repeat, just because that would be really, really simple to do. So, I mean, my gut feel is that I would approach the problem at first with taking, especially if there are different frequencies dramatically in time, I would use a hypertable for my weather data, hypertable for this sensor data, hypertable for that one, et cetera, with the correct columns in them. But in order to make the determination if it would be wise to deviate from that, we really need to see the queries that you're talking about doing, right? Because if, there's lots of different ways to skin a cat, right? Apologies to the cat owners. So when you say you're doing, joins, give us an example of a query where you're going to look at flood sensors and meteorological data, for example.
Yeah, that's a great question. So I think when we are, I guess one admin use case for us is on Grafana. We're going to overlay flood depth data with precipitation. That's one query. We have an API that's going to be sitting in front of Timescale, and that's researchers could do weird queries on it, and that could be give me all precipitation and all flood data over these common time ranges. That's the kind of query we could be looking at.
Yeah, so that doesn't sound to me like a complex kind of join. I mean, in Grafana, you would have two queries. You'd have one and the other, and you'd have two pens in there, and they would sit there beautifully on the display with their different time frequencies, et cetera. So that's Bob's your uncle on that one. As far as requesting the data, well, you just answered your own question there. If you're going to have your own API, then you have the ability to do all kinds of smart stuff, right? Now, what kind of volume are you talking about? Because you might consider prom scale if you're going to have really voluminous amounts of data.
I mean, yeah, it's data from 500 sensors every minute.
No, that's not voluminous. That's
yeah, it's not that big, and it's just that after 10 years of this operation of this network, there's going to be lots of rows, but I still don't think we're in the multi-billions of rows.
No. We were doing a project with sub-second data with vibration or fiber Bragg great, those fibers that measure the torque on bridges and things like that. It's all sub-second. So you wind up with, a vast amount of data in an hour. And so there we faced a big volume problem. But what you're describing does not sound like that kind of problem. I mean, the fact that it goes along for a long time, Timescale is absolutely wonderful at doing that because it knows I'm not going to look in that table because that's, 3 years after the data that I'm looking for, right? Just be sure that in all your queries you have where time between, as an absolutely key thing that you do.
That's great. And yeah, I guess it's not that big data, and but it's, yeah. So I mean, so the short answer would be that we should be okay with using a single hypertable, but just with this sparse data.
Yeah,
I know it's hard to say.
I would probably tend to using multiple hypertables. I think that's what you were saying, wasn't it? Right. Yeah. From my perspective, it's going to come down to like the only real benefit that we're going to see here is if you're doing lots of joins. And as he mentioned, we're not talking about joins where you just want to put stuff in Grafana together because you don't need to join that. Grafana is doing the join for you at display time. So it's if you actually want to do joins between multiple different tables and it's quite complex. So if I'm having to drag data out of 10 tables and join them all together, that could be an area where you want to optimize and have a really wide table because you cannot do the join. Doesn't really sound like you're doing that. You're just saying, I want to see these data points at the same time. You're not having any sort of logic that's trying to correlate them in the database. Is that right?
Let me dream up a query that might answer that question. Suppose that you wanted to ask for, give me the precipitation, that data, the meteorological data, that 1 hour before the flood sensors went above such and such a percentage.
Yeah.
So, James, how would you do that?
So, I mean, I still think that would not be something that you would need a wide table to do, right? Like it's maybe if we came up with an example that involved another 4 tables, we could be starting to get there. My other worry is before we jump into like examples of queries and stuff, like the amount of data. If we said it's definitely not big data, but it sounds like it's not even close. So if we start trying to put that into a wide table and compress it, and we've got lots of gaps in it, we're probably actually going to get. I don't think compression is going to be great. I actually think you'd possibly get a better compression rate having separate hypertables and compressing them than you would having one big one, to be honest.
That's great. That was one of my follow-ups, and because we imagine that compression would be great for us because we measure a lot of zeros. It doesn't flood that often, apart from the coastal areas, but yeah, we will have a lot of zeros. So I think that's good to hear that the compression will be more optimized if we're in separate hypertables.
Well, I mean, obviously the compression, having zeros is great for compression, so you'd be good either way. But the thing is, those zeros are just not going to exist if you have separate hypertables, right? I'm guessing, because you're only putting the data into the table when you actually get a reading for that particular thing. Whereas when you're doing a wide table, you're forcing a 0 into that data when there's a reading for something else. So
no, hang on a second. So a wide table would have a column for every single one of them, and you would put a value in it each time you made a recording for every single one. He's not talking about that. He's talking about a table, a hypertable, where he's got, let's say 11 different value columns, but 9 of them are not used, and he only makes a recording of this type or that type. So he, if it's I guess that's exactly the same thing, isn't it?
Well, it's actually worse, isn't it? So it's because you're best case scenario, you would have readings for multiple different things in one column, right? In an ideal world, if we could optimize this as far as you wanted to, if you had really big data, we might even say something like, let's have a continuous aggregate where we go and grab all the data for a 30-second period. We know we're going to have a value for everything. We're going to squash it all down into one row. If you wanted to go for optimal compression and you wanted to sacrifice sacrifice some values for that would be a great way to go. I really think that this question is coming down to you guys reaching for something that's similar to Influx, because in Influx, you do have a wide table model and you do just have a big bucket for everything. And I really think the answer is perhaps until you need to optimize this, maybe you should go back to a more relational model because that's Timescale's background. The other thing is when data isn't compressed, it means you don't have to go and get every value, because obviously you can't compress your first chunks. You're probably not going to compress all of your data because Timescale is Postgres and Postgres is relational. When you're getting uncompressed data, it's going to have to go and grab every row, regardless of if you're going to use it. So that's going to be incredibly suboptimal for data that hasn't been compressed yet. And I'm guessing that people are
more interested in the recent stuff.
Yeah, more often than not looking at the most recent data. Is that a fair?
Yep, absolutely. The different agencies that we work with really care about what just happened and what's happening right now. So yeah, immediate stuff.
Yeah, use multiple different hypertables. Especially because I'm guessing, because you just said different agencies, I'm guessing one agency is probably only going to be concerned with a subset of those values, right? And then another agency might be concerned with another overlapping subset. Is that how it works?
Yeah, we have agencies that focus on the coastal flooding, and they will only look at particular data in a different way. Then you've got the Office of Emergency Management, who will do more prescriptive after the event kind of analysis of these floods. So yeah, different use cases.
Yeah, so I think start with multiple hypertables. If you were to come back in a couple of months or a year and say, we've got too much data, then we could talk about maybe using a wide model to try and get better compression. I don't think that's going to happen. The amount of data you've got, it's going to compress well from what it sounds like. I don't think we're going to be having any sort of discussion like that unless you get at least an order of magnitude bigger.
Okay, fantastic. Thank you so much. I have more questions, but I'm happy to save them for later.
Okay.
Well, no, I mean,
let's see. I mean, we can carry on. we haven't got any others scheduled. I mean, David's popped in. He sometimes has some ad hocs for us, and Michael too, Brandon. But yeah, I mean,
I think let's keep going on the
they
same
usually
tack.
they look after themselves, Charlie. So don't worry about that.
Okay,
in the past, they've always looked after themselves. So, okay, yeah, carry on.
I have a question about multi-node and what the roadmap is for that. Because we're running everything in-house at the moment, and we're migrating everything to a cloud offering, probably Google's, and we would like to have a multi-node setup with Timescale. We're using Kubernetes to spin these things up, and just wondering about the timeline for multi-node and whether it's available with us running it, but also then to explore the cloud options, because I believe it's already running with the cloud offering.
Yeah, okay. So multi-node is available today. It's available if you want to install it yourself, you can use it. It's also available via Timescale Cloud. I think it's opt-in though, so you have to get us to enable it for you. Multi-node works, but I can't see a way that you're going to get to a place that you need multi-node, to be really honest about it.
Okay.
Unless you've got something coming up in your roadmap that's going to vastly blow out the amount of data that you've got. And Lorraine's showing a demonstration of that. I don't think you sound like the type of customer that would benefit from multi-node.
Are you talking about multi-node for high availability?
Yeah, it's high availability, and also the potential that if we blow up, if we have a public blow up, then we have a lot of people hitting the API to maybe handle larger loads of traffic.
Right. I'm going to backtrack. Timescale has a feature which we call multi-node. I think then what you're just talking about is HA and having read replicas. So that's a feature that we piggyback off Postgres for. So Postgres has streaming replication. You can stream to another Postgres server. If there's a failure event, that server can then take over. If there isn't a failure event, you can still then read from that server. You can't write to it, but you can read from it. That sounds like what you're talking about, I think.
Yeah, that's it. That's it.
Yeah, and I do that, and I've done that a bunch. What we really wish is that Postgres did a better job in sort of hand-holding you through all of this, but it doesn't, right? So you have it's some technical stuff you have to do and tweak this file and restart this node, etc. But we've worked our way through all those issues. I can give you a hand. If you send me a DM, I'll send you some of the scripts that we developed to do that.
That's fantastic.
I mean, there's
we were looking at the I'm kind of reading what B has asked me to ask. So she's asked is it worth starting with your multi-node Helm charts marked as in development?
No. So we've got to be a bit careful here. When we're talking about multi-node, at the Timescale multi-node product is for like petabyte scale data. It's not actually for HA, which is a mistake that lots of people make. So if one of those multi-node, it's like a sharding system, I suppose is the keyword we should be using here. So if one of those nodes blows up at the moment, you would lose a subset of your data unless you had HA on every single one of those nodes. You guys don't need that. It sounds like I would argue that you would probably never need it. So I've had Timescale instances that are easily serving sort of 200 terabytes of data. I don't think, I'm guessing, unless there's a lot more sensors that are all of a sudden added, you're not going to get there. So yeah, what you're looking for is Postgres. The thing you want to search for is streaming replication. That's core Postgres. Timescale doesn't really come into that at all. There's a bunch of products that can help you with that. The one that we tend to use is called 𝗥𝗲𝗃𝗃. 𝗥𝗲𝗃𝗃, actually, now I think about it, is probably the solution that most people use. There's another one called Rep Manager that was from Second Quadrant. Second Quadrant got acquired by EDB. That's kind of fallen out of grace now. We use 𝗥𝗃𝗃 and Timescale Cloud. All of the big cloud vendors, including Amazon, although they've never publicly called it out, use 𝗥𝗃𝗃. Having said that,
James,
you can manage it by script as well.
As long as we're on the topic here, In your instructions, and from my experience as well, from the Timescale replication documentation webpage, the first step is to do a backup, right? A base backup. And you get this error message that comes from it, which says your data is in hypertables and will not be duplicated. This fails, is what it's telling you. But your comment says, no, don't worry about that. It really does work. And it is my experience that it really does work. But you really do get this error message. I'm trying to find the web page where it says that when you just start this. You know what I'm talking about?
Are you talking about a base backup, or are you talking about a PG dump? You're talking about a base backup. I
think base backup. Replication parameters. Create the replication size. Maybe it's the PG dump that gives you this error message.
I think it's PG. So PG dump is obviously like a logical dump. It's going to give you SQL commands. PG base backup. It would surprise me if they ever happen. All it's really doing under the hood
is copying the whole folder.
Copying the files. Yeah. So there's a command you have to run before you start, which it does for you if you run that. But
yeah, so that's right. On PG dump, I get an error message that it tells me I can safely ignore, and but still, that's sort of concerning, right?
Yeah, so basically what that's saying is you can't just PG dump a hypertable on its own. So you can't use -t with the hypertable name, because then you wouldn't get the timescale metadata. You're trying to dump the whole database so you can safely ignore that. But you're right, it would be good if we could look at what you were dumping and then work it out and only put the error message out if you're doing something wrong. Okay, I'll take that back to the team as feedback.
My experience has been that I haven't had any problems, and the message just frightens my users.
Yeah. If the user was to try and
hide the message from your users, that's.
There's my user right there. Speaking up.
Exactly. So I did have one question that goes along with this, and that is also in your documentation you say that you use PG backrest along with 𝗥𝗏𝗃, and I just wonder if you could speak a little bit about the utility of using those together, and whether that's recommended for mortals as well.
So it's more recommended for mortals than for people who are very good at Postgres. So backrest is an absolutely stellar bit of software. There used to be quite a bit of fragmentation in the Postgres backup world. I can quite confidently say that PG backrest is now, unless you're doing something specific, like unless you're living in an AWS world and you only want to send your data to S3 and you don't care about anything else, in which case you could still use backrest. But there are some niche ones that just operate in that space. PG backrest is the backup software that you should be using for Postgres.
Okay.
It's written by a guy who works for Crunchy Data called David Steele, who I'm actually having lunch with tomorrow. Turns out he's in Sydney. Yeah, it's amazing. It's great software. Very fast. I've used it previously on as I said, a 200 terabyte database. We were able to do restores of a 200 terabyte database, which obviously takes a while, but is impressive. Other bits of backup software we tried just fell over in the middle with flaky. Backrest just works. 𝗥𝗏𝗃 knows how to use backrest by itself, so it can drive backrest for you.
Okay.
So that's why you see people talking about the link between those two.
So one is more of like an orchestrator, I guess, maybe.
Yeah, so when you're doing high availability, as we mentioned before, the first step that you have to do is take a backup of your master server to push out to your other servers. So 𝗥𝗏𝗃 will know how to take a backup, and then it will push that out to those servers.
Okay, cool.
I don't know this for sure. I can comment on Timescale Cloud, and I can comment on, I believe, the EDB cloud product, I think. I would hazard a guess that at this stage, all cloud products use PG backrest, because that's where the development goes. That's moving a lot faster than any of the other ones. Maybe AWS has got their own one because they might be using snapshots, but
wouldn't it be terrific if this terrific piece of software was actually part of Postgres?
Yeah, so I mean that's like a fundamental thing that comes around the lists every year or so. So the Postgres developers would say, we don't want to pull in complex bits of software, in the same way that it would be great if you could have HA in core in Postgres, right? It's very much because Postgres came from a university mindset. It does one thing and it does it well. It's like the Unix kind of methodology. There are slow inroads to that being made. So there has been some stuff which has been pushed in the last couple of years that is sort of paving the way for the in-core backup stuff to get better. But it's a slow road. And PG backrest and Pt are complicated bits of software. Pt in particular will never be core because it uses Raft under the hood. It's like a whole other thing. Backrest, you never know. One day, maybe there'll be something like that. I mean, ideally, from my point of view, which is quite biased, as someone that deploys complex Postgres systems in my history, PG backrest would replace PG-based backup, but I don't think that's going to happen. PG-based backup is a minimum viable product for doing Postgres backups. PG backrest is a whole other thing. It talks to all the cloud providers, it does S3 streaming, all of that kind of stuff.
Scheduling, getting rid of the old ones when they expire, all kinds of good
retention,
stuff.
Yeah. All of the stuff that you need if you're running in an enterprise, exactly.
Terrific.
Okay, I'm just popping in now because over in the chat, Brandon's got a question. There's some figures in there. Again, I think that there's something we can help out with here. New to TimescaleDB and Postgres, trying to get everything in order so he gets everything in mind. Had a look at TimescaleDB Tune tool. There's a bunch of figures there. If you're happy, can you see them, James? Yeah, you can see them.
Yeah,
Everyone can
I can see them.
Yeah, cool. Thoughts behind the suggested settings using TimescaleDB with PromScale to ingest Prometheus metrics from 33 Kubernetes clusters. Happy to take the question to Slack. Yes, it is exciting. It is exciting. These guys love to talk about PromScale as well, by the way. And James is a big PromScale person too. So fire away. Yeah. Who wants to lead? You going off with that, James?
Yeah, cool. So first of all, it's great that you're looking at the values that come out of TimescaleDB Tune, because I think quite often people just blindly accept them. So it's really good to see people actually looking at the values and asking questions about them. Basically, the reason it's giving you more max worker processors than your CPUs, which does actually seem counterintuitive, is because Timescale makes heavy use of worker processors for internal things. And also the worker processors used by Postgres to do parallel query. So we're sort of saying we're going to give you slightly more than your CPU so we can slightly oversubscribe there. That's quite a normal thing.
We're getting sage nods there from Frank. Yeah, we'll just go with the sage nods on that.
I trusted.
I just used to
I trust the auto tune. So
okay.
Yeah. So what else we got here? So we're for a little bit of background. I'm using TimescaleDB and PromScale. Yeah, okay, right. So this is particularly true in PromScale because PromScale does stuff a lot more aggressively than Timescale would. So PromScale will be using more background workers than Postgres actually does or Timescale actually does. Because often we're seeing a lot smaller chunk size, things are compressing a lot faster, that kind of thing. In fact, one of the most common problems we see with people running PromScale is that they're like, my background workers aren't keeping up, which is almost always because they don't have enough background workers or enough CPUs, one of the two. Great to see a PromScale user, great to see PromScale questions. I'm actually quite new to Timescale. I started in February, which seems like an age ago, but quite recent. I actually started as developer advocate within the PromScale team. Yeah, good to see it out there in the wild.
Follow-up PromScale question then, if it's okay to jump in.
This one.
Yep.
So is there anything now, I see that PromScale's shipping ARM64 images on Docker. So is there anything that prevents us from putting a full-on PromScale image out on a IoT device running ARM?
No, I mean, the image is there.
And until just recently, there were AMD64 and there was this and that. I mean, there was ARM for TimescaleDB, but not for the other pieces. And so now it looks like all the pieces exist. So is there anything that would just prevent us from putting a lightweight edge-based timescale on a Raspberry?
Absolutely not. That's exactly why that exists, because we've had people asking that question.
Yeah.
So I think previously the only reason it wasn't there was because with our build process, it was quite difficult to get at those artifacts in a nice way. So we had to jump through a lot of hoops. There's been a lot of improvement done there. So now everything you'll see coming out on every architecture.
That is super fantastic. That leads me to my final $64 question, and that is about extensions. So we have struggled mightily with keeping the moving parts all synchronized, unless we're using an image that comes from you with them already baked in. So the HA image has a bunch of stuff we don't need, but we need it because it's got toolkit and other things that are already working. All PromScale extensions already there. So what my question is, have you done work to allow surgical migration of extensions in any way? Because right now it seems like if we've got a backup that's on Timescale 2.6.1 or whatever, and we want to migrate to a new collection, it's quite a bunch of hoops to jump through to spin up a dummy image, to do things, get things in the right version, and then move the data and then spin it up. It's just a disaster. So it seems like you talked recently in the GitHub about moving to build so that people can do binary releases of their packages, and it was a mystery to me, at least, what exactly that was referring to. Does it have anything to do with this kind of the granularity of upgrades, in an enterprise?
Yeah, so I didn't see that comment, and I'm not 100% sure what that would mean, actually. But I do absolutely feel your pain that this can be something on the PromScale side, because in the PromScale, for people that haven't used PromScale, there's a PromScale application and there's also a PromScale extension, and those two have to be in sync. And
that's mandatory now. So you can't just, in the past we ignored it and just said, oh yeah. It'll be maybe we'll get a performance hit, but it'll work. Now it's mandatory to move along with the current releases. So it's really essential to at some point talk about surgical upgrades in an enterprise where you can't just say, oh, just spin up a flat container and start over. No.
Yeah, absolutely.
We don't have that option.
Yeah, so I mean, just to, I suppose, give a bit of history, that the reason that it's required now is because the extension's doing more heavy lifting. Before it was just for one particular type of PromQL query. Now it's used to make things a lot faster across the board.
And that's great.
Yeah, but the question stands. Yeah, that's something I would like to see being a lot better, and it's definitely something the team is aware of. I think for PromScale, at the moment, the focus is on performance. I think once we've got past the performance epic that they're doing, then we'll come back and we'll be looking at things like this. So I'll talk to Ramon and get that put in the backlog, or make sure it's already in the backlog if you'd like.
I'd like to at least be able to take the image that you've got of Timescale DB, which is great. It's on Alpine. It's a lovely svelte little thing, wearing a little black dress. But I'd like to take that and then add to it the stuff necessary, without going all the way to, okay, now I have to run it on AMD because I need the HA image. Well, that's fine for the big iron and the big guys in the cloud like you. But on the little guy side, I'd love to be able to take the three pieces and know that they're going to work together.
Yeah. So the problem is that you can get the three pieces and you can make them work together, but you've got to go and work out exact versions and make sure it all matches. Is that what we're saying here?
Yeah, and it's a mess. And it's really four pieces, I guess, now, right? So it's the toolkit extension, PromScale extension, PromScale, and Timescale. And ideally it works all as one system, and that's what we pretend inside.
Yeah, and I suppose going back to your previous point, if you had data from an older version of Timescale, the way Timescale upgrades work at the moment, you might have to jump through a version in between to get to the version you want to go to.
Yeah, and that's okay, but we've actually run into places where we cannot upgrade because the number of versions that you allow to be different in the target system is like only 2 minor or something like that. It's a very small number. Like if we're not upgrading every week, we're out of luck, and that's kind of unrealistic in an enterprise. It might be great in the cloud because you got one thing, right? You got a whole team, you're working on one thing, but in an enterprise, it's not your only job. So
yeah, exactly. No, completely. I mean, in my previous life, I would have probably flat out rejected software that did that. Can I ask you to make an issue in our GitHub, and then I will jump on it? I think we have issues for this stuff separately, but I don't know if anyone's actually created an issue that links all these together.
We've done it,
and if we
can
can get
other stuff, and work with different guys like James, you're the other James, and then it's been great, but it would be so much better if the mainstream folks knew how painful it is in an enterprise to not be able to upgrade just the piece that you need to upgrade, or for that matter, migrate from one to another without without hoping that something doesn't go wrong.
Yeah, cool.
So
yeah,
Frank's our wordsmith. I'll work with him to make sure that we word this correctly and get it exactly, precisely posted. So you want it in GitHub?
I think that's probably easiest. If you want to, or the other option is we can chat on Slack and we can go through exactly how you want to word it. Up to you, but I think GitHub would be best. Probably the timescale GitHub, even though it's somewhat a prom scale question.
Well, you guys are a big happy family, so we hope that you talk to each other.
Exactly. The reason I say there is it gets more visibility there. But yeah, if you put something on GitHub and then you ping me on Slack, or I'll probably see it anyway, then I can start jumping up and down.
You can +1 it. Okay, cool. Thanks.
David, you popped a question in there, but I think it might have just been in amongst that conversation then about a more extension model like toolkit. Did you still want to? Is that something you wanted to bring into this, or?
I think they kind of touched on it. Hopefully, you can hear me.
Yeah.
Okay. Yeah, they kind of touched on it. I just have one other question, but I'm going to wait until the last to jump on it.
Oh, okay. All right. So, any more questions from the field? Otherwise, we'll move on to this slide and David can decide when he wants to make his jump on in. Okay. We have some upcoming events with the Timescale team. We're in Detroit, which is where Kaylin is. Next week, we're also in Berlin with PGConf.eu. So you can find all kinds of Timescale team members there. We'll be at AWS reInvent at the end of November. We love to do meetups. And if you have a meetup or would like to invite a Timescaler along to come and talk with you or a group, we're always open to that. So community@timescale.com.
And I don't know where people are, but if anyone's going to any of those conferences, then definitely go and find the members of the advocacy team. I think Mathis is going to be at KubeCon. We've got 4 people in Berlin. So Chris, Denma, and Kirk are going to be there. And then Kirk and myself and Mathis are going to be at reInvent. I'm going to be horribly jet lagged, so come and say hi.
Perfect. And so this looks like this is your opportunity, David, because I've got my thanks for joining us slide up. So
go, David.
Okay, I'll post it because I was going to type it in also. But Frank talked about his bridge project, and I assume he was looking at seismic data to see if the bridge was moving. Did you have any insights on real-time outlier detection for that, weaknesses and strength of timescales functions? And I'm really looking at FFTs as a basic feature of sampling data as it comes in. I'd love to see it supported in Timescale on the database side. If you had any ideas about that, since you're facing a problem that's kind of similar to what I have, which is lots of data and trying to figure out ways even in Timescale to reduce it.
So I know what FFT stands for, Fast Fourier Transform, but that's where my level of technical expertise ends.
Okay.
The algorithms that were being used to analyze the data, well, that was not my end of the project, right? I'm about collecting data and moving the data around.
Okay. So what do you do or do you have any thoughts on outlier detection, on getting all that data in real time, or did you just look at that later?
Well, it's a multi-step thing, right? So the ingestion of the raw data happened, and we were able to get a sustainable 1.2 million inserts per second going into a reasonably pedestrian set of hardware. So that was very happy on our side. And then the actual data processing side was separate from that, and doing the different algorithms like calculating strain and other kind of things from the raw data. And it wasn't really seismic; it was more, fiber optic measurements. But they're coming in at about 50 hertz times 300 sensors on a single bridge, and there's no trouble keeping up. So we're just super happy with the prompt scale ingestion and the ability to then run triggers based on when things happen, to then run that post processing. All of our stuff was in Python in that particular implementation.
So you didn't have anything on the ingress. I'm always thinking the closer I can get to actually writing the data, I'm going to be happier. And like FFTs or anything to reduce complexity.
So we did it in flight. So it was all done using streams, but that was done prior to the insertion. So just for the data processing part, we did a lot of in-flight calculations that were that took the raw data and made other, essentially raw data, but derived data, like soft sensors. But it's the same thing. I mean, in our particular case, the raw data actually came from Parquet files in S3. So there was somebody at the other end, hardware guys, stuffing things into Parquet files, and we were taking them out as fast as they could put them in. And that was their true backstop raw data backup. So we were the front end processing and display component. But the FFTs would be really no more difficult than the stuff that we were doing at all.
Yeah, that's all on the pre-processing side, though. I'm wondering if that's kind of where I'm homing in on for an extension for the toolkit, or part of the toolkit, or part of Timescale altogether, is just have something that actually like the time buckets that you could throw data in and do an FFT on, which I think would be probably an order of magnitude faster and better for data ingestion. And that's where I'm kind of thinking. Huh?
It doesn't seem difficult really at all with almost any calc engine that we've come across. So the timescale stuff is not going to be the bottleneck.
Well, if you can run it on the server, then you don't have to run it on something else that then talks to the server.
Well, just run, just spin up another container for your ML and do it there. I mean, if you got a hardware that can take it, just pound it. I mean,
so I think where you're coming, this is actually something that I've been thinking about a little bit recently. So it would be great if you could have a hypertable that never got written to disk, and you wrote the data into that hypertable. It was memory only, and then you could transform that to then be on disk. That's kind of what you're asking for, right?
Correct.
You want to get I
so want
that
the
is
same,
something.
I want the same kind of action you have in the time buckets, where you literally can write that data and then it will aggregate it correctly. But instead of aggregating, I want to run an FFT on it. So I don't have to be shuttling it around to a processor somewhere else and then send it, even with as fast as they are today. It's more of an issue on how many servers we're going to have, and it's a cost benefit thing. I need to get the cost down as low as possible. And, especially the way that a lot of the cloud systems are on, I don't want a huge amount of data, but if I want the fastest stuff, then I've got to get cloud services with huge amounts of data, even if I'm not going to use it, because they kind of scale together.
Yeah. So I think, as we're saying, that the normal way that people would do that would be they would handle that in the thing that was writing the data into the database. So
you put your raw data that goes into a hypertable that has a retention period which is relatively small, and subsequent to that you're running a continuous aggregate, which is doing your continuous aggregate, and your continuous aggregate can be whatever, whether you can use one of the built-in ones or not. You can certainly do what I was talking about in the very beginning of the call, which is you could send blocks of data to R and have R do the fast Fourier transform, similar in SciPy or Python Pandas or whatever.
On the same box, right?
On the same box.
Yeah, right.
Maybe it's in another container, or maybe it's just in a piece of code that you wrote, and then you have this reduced data, this filtered data, this analyzed data, aggregate data, and you put it into this other table, and that other table has the retention period that goes for years, right? So you never keep around the raw data that's unprocessed for too long.
Yeah, I mean, I suppose the line is whether or not you want to thrash your disk with writing data you're going to throw away straight away. I suppose that's really what we're talking about.
Oh, yeah, I think the idea of having a memory resident hypertable would be a great feature.
Yeah.
Also, have nice FFT and Rust that you guys write for us. That would be super great too. Thanks.
So in your idea of this hypothetical memory table, how would we manipulate the data if we wanted to do something unless they wrote something custom to actually manipulate that table? That's where I get back into, is there some kind of extension so that we could write maybe a small bit of Rust and leverage the bigger part of Timescale?
Yeah, write a hyperfunction.
Yeah.
There's several examples out there.
Okay.
In fact, I've got a talk on writing Rust functions with PGX. I'm actually a contributor to the PGX project. If you need help there, I'm more than willing to reach out.
Do you have that link? Do you have a link for that
link for the talk? Yeah, I will find it afterwards and send it to you.
Okay.
That's fine. I think, Lorraine, you've got his details. Yeah, cool. Yeah, I gave it at PGConf. This one's not recorded, but the talk, the larger talk was for PGConf in, where was it? Austria? No. Czechoslovakia. Here we go. One of them. Yeah. But yeah, I'm more than happy to help out with that kind of stuff. I suspect if you start asking questions about PGX in the Slack channel as well, in the right channel, then you'll get quite a few responses, because we've got quite a few people internally at Timescale that are really jumping on the Rust bandwagon at the moment. In fact, we have internal Rust language learning groups happening every week. So it's very much front of our mind at the moment. I had one question about the R stuff, going back to that for a second. Why not just use in database R with PGR?
Didn't know about it.
So there's obviously Postgres lets you use lots of languages, and one of them is R. So you can actually run R from within your database. It can be a little bit unwieldy at times, but obviously it removes a whole hop, right? You don't have to pull all of the data out.
Yeah, so the two reasons for that. One would be, if I remember correctly, I just read the release notes for Postgres 15, and some language had been removed, deprecated spontaneously. Was it PL Python?
So no, yeah, that's Python 2.
Oh.
So I mean, so that's been deprecated because Python 2 has been dead for 2 years at this stage.
Yeah, okay. So I'm glad to hear that. So then the next reason is we kind of want to separate these two activities. One is a user activity, and one is the data activity. So I want my users to be able to dream up whatever they're going to dream up and be able to do it, and I don't necessarily want to embed it inside the database. But that's I'm aware of the PG languages. We've used Python, and we've used PGPL, PGPLP, whatever it's called, SQL, right? So no, I didn't know that R was available that way. That'd be an interesting thing to examine as well. Thank you.
So I think that makes sense for your use case, because you don't want the users to swamp your database by creating a massive R query, right? Yeah.
I haven't looked at 15 yet, but I take it there's no internal Rust on PG15? It's
in
just
Postgres?
another language?
Do you mean, is there a PG Rust? Is that the question? Or is it, well, so yeah, there is. So the team that works on PGX, so there's a guy called Eric, he goes by ZomboDB on Twitter. He has a similar project, which I forget who's heading that up, but they're doing a PG Rust language. Obviously, it's a little bit more problematic because Rust's a compiled language. So as soon as you create a function, the database then has to go and compile it, which means that you have to have a compiler on your database server, which can raise a few eyebrows. It's doing all sorts of smart things to sandbox the Rust code. So I think it sandboxed it in WASM, I think. It's not something that you can really, I would suggest using at the moment, but it's definitely something I've got my eye on. I check in with them quite regularly to see how they're going. So I think once they get it going, it's going to be a massive thing for cloud vendors, because at the moment, Postgres has this definition where there's like trusted languages and untrusted languages. A trusted language is something that can't have any side effects at the operating system or database level. So you can't use it as a vector for a malicious attack. If they can get Rust in there as a trusted language, then it's going to be massive because it's going to be a lot faster.
I put in the link what I think is the GitHub page for PL Rust, and similarly there's PLR.
Yeah. Thank you.
Perfect. Well, we are at the top of the hour, everybody, and we went from having a very sparse little office hours to having a very busy one. So I thank you all for that and for your contributions. That's been amazing. I know that Charlie would like to be in touch with you, Frank, so I'll just email you about that maybe afterwards, just checking with you. Any more? Otherwise, we'll say goodbye for this month, and we'll see you next month.
Thanks, everybody.
Thank you. Thanks a lot. See you soon. Bye-bye.
Bye.